So let's take a look at some of the most important information that I hope you know, or I will be happy to let you in on this camera. So this camera is a digital single lens reflex camera. And one of the most important parts about that is that it has one main lens that the light is traveling through. It's a very high quality lens, and that is how you view the camera, you view the image as well as take the picture. Now there are lots of different lenses. There are wide angle lenses, there are telephoto lenses, and there are zoom lenses. And there's a lot more in lenses, but unfortunately this class doesn't have time to talk all about the lenses, which is a great subject. Now when you focus, the lens elements will move back and forth to adjust for subjects that are closer to you or further away from you. Within the lens is an aperture unit. It's basically a hallway of light that can open and close. It never closes completely, but it allows you to control the amount of light coming in the lens. And so if we have a lens that starts at 1.4 and is wide open, and as we close down, each f-stop or aperture setting will close the amount of light and reduce it by 50%. Excuse me, by 100%. 50%, sorry. 100%, that'd be a lot of light. Basically, you're doubling or you're cutting the amount of light in half with each of these aperture changes. And so it's a great way for controlling light coming in the lens. Now the second thing is that this aperture also controls the depth of field. And so if we were to take this imaginary lens and open it up to f1.4, it would have a very shallow depth of field. And so you can see the red hash marks over on the right hand side. That's indicating the area of focus, the depth of field. And as we change this aperture from 2.8 to f4, we're going to get more depth of field. And each step along the way, we get more and more depth of field. It's not a dramatic change at any one step, but it does add up to quite a big difference between the lens being fully wide open and the lens fully closed down. And using this for creative control and artistic reasons is very important in photography, as well as simply controlling the amount of light coming in the camera. So back to our camera. As light comes in through the lens, it will then hit the mirror, and that is the reflex portion of the digital single lens reflex. Now the mirror is going to bounce the light upwards so that we can see what is going on. It's going to project an image onto the ground glass, and in order to see that ground glass more easily, the light is going to be bounced around through a prism system and through a diopter, which is where we look through our camera in the viewfinder. And this makes the camera very convenient, easy to use, and it also allows us to see exactly what our camera is pointed at. We can see how telephoto or wide angle our lens is. We can see the effects of using filters. It's a very good system for a camera. Now, when you press the shutter release, the mirror needs to get up and out of the way so the light can make its way back to the image sensor. And so the image sensor is a very important part about the camera. We're going to talk a little bit more about this, but the size of it and the capabilities in low light, as well as its resolution, are some of its most important characteristics. But before the light gets back to the image sensor, it must pass through the shutter. And the shutter is a two-part system. There's a first shutter and a second shutter. And when you press the shutter release button, the mirror goes up. A first curtain will open up, allowing light to come into the sensor to expose the sensor for the image, and then a second curtain will come down and block the light off. When it's all finished, the mirror pops back down and returns the light through the viewfinder so that you can see what's going on. One important thing to note is that you do not get to see what's happening while you are taking a picture. So if you saw it through the viewfinder, you missed it. That's why you need to anticipate with these cameras. Now, that shutter unit is really important for controlling the amount of light as well as controlling the way our subjects look in there. And so let's take a look at some shutter speeds. Here we are at 2,000th of a second, a very fast shutter speed for stopping something moving very quick like a bird in flight. A 500th of a second is a good shutter speed for stopping human action. So if you want to stop somebody in sports or dance or anything like that, 500th of a second is a good shutter speed for that. 125th, kind of a moderate shutter speed, is suitable for stopping some camels walking casually in the desert. When we go down to a 30th of a second, we're getting to a slower shutter speed. Here you can see that we've got a lot of blurriness because our subjects are moving very, very quickly. Down at an 1/8 of a second, You'll notice that the bridge at the bottom of the frame is sharp and in focus because a tripod was used for this shot, but the people are blurry because they are walking at a casual pace. As we get into some slow shutter speeds at 1/2 of a second here, water crashing over a rock is going to look very blurry because it moves quite a bit in that period of time. And all the way down at 30 seconds, this may look like mist or clouds around mountaintops. It's actually water flowing in and around rocks on the shoreline of a beach. And so those very long shutter speeds can be very interesting on getting some fun results from that. So we talked a little bit about that sensor, and I want to talk more about the size of the sensor. When you go into the camera store and you look at all the wonderful cameras that are available today, what may not be apparent to many purchasers of said cameras is the size and type of the sensor in the camera. And there is a variety of sensors in the cameras that are on the market today. And that is, as I said, one of the most important factors on the camera. And what's really important is the exact size of the sensor. So let's talk a bit about the size of the sensor. And we're going to be looking at the cameras that use interchangeable lenses, the main SLRs out there, and they use the 3 larger sizes. The D7000 uses one of the largest ones out there. Now, the largest one out there is the exact same size as 35mm film. And those of you who shot 35mm, familiar with that. It's 24 by 36 millimeters in size, and they do make sensors that are exactly that size. And they call them full-frame sensors. And it has what's called a crop factor of 1.0 because it's exactly the same as the 35mm standard. Now, these sensors are great. The only problem is that they cost a lot of money. And so in order to save money, different manufacturers have made smaller sensors. The one in use in the Nikon D7000 is what Nikon calls a DX sensor. It's a little bit smaller, 16 by 24 millimeters, and it has a crop factor of 1.5. It doesn't see as much. It's basically 1.5 times smaller than the full frame sensor. So lenses will look a little bit differently as we go from full frame to DX. And we will talk more about this when we talk about lenses and accessories for this camera. The other standard is used that is pretty common out there is the APS-C, which is just a little bit smaller, that has a 1.6x sensor. But the one in your Nikon here has a 1.5 sensor. So that's a little bit about the digital single lens reflex. If there is more that you would like to learn about this, you may want to check out the Fundamentals of Digital Photography. It's a downloadable